You know that thick, stubborn black wire behind your desk connecting your monitor?
Oh yeah, the one you always struggle to bend into place.
Exactly. Well, what if I told you there's a version of it that actually fires data using tiny lasers at the speed of light, and it costs over 300 bucks?
That is a serious cord.
Right. Welcome to today's deep dive. We are looking at the specs you shared for a piece of optical engineering that is basically disguised as a 7.5-meter computer cord.
Specifically, we're looking at the DVIGear DVI-2807-AOC HyperLight DisplayPort 1.4 cable.
That is quite a mouthful.
It is, yeah. But to understand that heavy price tag, you really have to look at the physical limits of traditional cables. Like when you try to push 8K video resolution or even super fast 4K at 120 hertz, you're dealing with an absolute fire hose of data.
We're talking up to 32.4 gigabits per second, right?
Exactly. And moving that massive amount of data over a standard copper wire for 7.5 meters, let alone 100 meters, which some of the longer versions of this cable can actually do, is a huge problem.
Because copper physically degrades the signal over long distances, the electrical resistance basically turns all that high-res data into
Heat. Yeah, it literally smudges the picture before it ever reaches the screen.
Wow.
That physical limitation is exactly why this cable uses a hybrid design. Inside that standard-looking black jacket, it's actually running 4 separate glass optical fibers right alongside 6 traditional copper wires.
Wait, glass fibers?
Yep. The transmitter end contains these tiny 850 nanometer VCSEL lasers. They're essentially microscopic lasers that instantly convert your heavy video signal into light.
Okay, so it's like a hybrid transit system. Like the lasers in the glass handle the massive 8K video freight at the speed of light, while those 6 copper tracks handle the basic admin stuff.
The admin stuff, exactly.
Yeah, I'm talking about the low bandwidth data, like the digital handshake that tells your computer what kind of monitor is plugged in, or the standard copy protection checks.
And what's really fascinating here is the efficiency of that dual system. The entire laser-driven process is ultra-low power. I mean, it pulls less than 0.43 watts directly from your source device.
Oh, so you don't need to plug it into the wall with some bulky external power brick just to fire the lasers?
Nope, not at all. It just draws what it needs right from the port.
That's awesome. The lasers definitely solve the data traffic jam. But as someone who has wrestled trying to fish a standard display cable behind a wall mount, how do you physically route this thing through a complex building?
Right, because DisplayPort connectors are usually pretty chunky.
Extremely chunky. You can't just pull them through a tight pipe.
Well, the engineers actually solved that by making the ends detachable.
Oh, really?
Yeah. Out of the box, the ends are these low-profile microconnectors. They're tiny, under 8 by 11 millimeters, so they easily slide right through tight conduits.
That makes so much sense.
And once you've pulled the wire to its destination, those tiny ends just snap securely into the full-size docking connectors. The jacket itself is also plenum rated, ULCMPOF.
Meaning the coating is made from specialized materials that won't release toxic smoke if there's ever a fire inside the ceiling.
You got it. It's strictly designed for safe, in-ceiling installation.
Wait, hold on though. We're talking about glass. If I'm yanking a cable through drywall and pulling it around tight ceiling corners, isn't the glass going to just shatter immediately?
You definitely think so. You can't just treat fiber optics like a cheap extension cord.
Right.
But the jacketing and how the glass is layered gives it insane durability. It has a bend radius of just 35 millimeters.
Oh, wow. Meaning you can loop it incredibly tight without snapping the fibers inside.
Exactly. It can also withstand over 250 newtons of pulling force, plus 500 newtons of crush resistance.
That is wild for glass. But here's where it gets really interesting to me. Because this cable relies on light rather than just electrical currents, it inadvertently solves another huge problem in professional AV, doesn't it?
Oh, absolutely. Environmental interference. When you run a standard copper cable past heavy machinery, power lines, or dense server racks, that invisible electrical noise bleeds right into the copper.
And that scrambles the signal.
Yes. But because this cable's transmission path is strictly optical, the light simply doesn't care about magnetic fields. It's completely immune to that RFI and EMI interference.
So beyond just getting a crystal clear 4K picture, does this invisible shield make it necessary for, like, high security, James Bond style
I
facilities?
mean, when you're dealing with sensitive, mission-critical applications, security and reliability are everything. This cable boasts a mean time between failures of over 150,000 hours.
Wait, 150,000, that is over 17 years of continuous operation.
Right. Combine that unfailing reliability with a signal that can't be easily intercepted or degraded by outside noise, and it becomes strictly suited for environments where failure simply isn't an option.
So what does this all mean for you listening? When you look at a $335 price tag, it's easy to experience sticker shock. But what you're really looking at is a bridge between the physical limits of traditional copper and the future of fiber optics.
And right now, this kind of hybrid tech is highly specialized. It's largely reserved for commercial setups and those massive cable runs.
Which leaves you with something pretty wild to ponder. Since this cable relies on converting electrical signals to light using tiny lasers just to bypass data bottlenecks, what happens when all our personal household devices hit the absolute data limit of standard copper?
That is the big question.
Will we all have microscopic fiber optic lasers living behind our living room TVs soon?
The next time you look at that stubborn black wire behind your desk, you might just wonder how long it has left before it's replaced entirely by light.